In this video, we'll finally see why Unix is useful specifically for language technology. We'll see two examples of language processing tasks that you can accomplish using Unix commands. Now let's start with the first one, which is a classical demonstration of the power of Unix command line tools, namely forming a frequency list of the words in a text. I'm currently in the week 2 subdirectory of my cmdline course directory, and I have here the familiar text file lifeofb.txt. And our aim is to form a file lifeofb.freq or frec, and let's look at it using less. We have words here and their counts in this file lifeofb.txt, and these are sorted according to frequency. And as you can see, the most frequent word in lifeofb is the, which occurs 4,602 times. The first few dozen of words are very typical for English text. Only later we get words like hive, which are, or bees, which are more typical for the text life of bees. Okay, so how do you create this type of a frequency list? Well, let's start with the file lifeofb.txt again. We can open it using cat. And let's pipe it to less so that we can see how it looks. So we have here lines of a dozen or so words, and in between we have some empty lines. Okay, and as familiar, Q quits. So the first step is to transform this to one word per line format. So press up to get the previous command. And to do this, we're going to use tr, or the translate command. So tr, and then in single quotes, -n, -r, -t, and space. These are all the white space characters, line feed, carriage return, and tabulator, as well as the word space. And then we have the replacement, which is just going to be a new line character. So this ensures that all words will now be on their own separate lines. Okay, let's again use less to see what the result looks like. Now you can see that there are a whole lot of empty lines here. And this happens because we may sometimes have several white space characters after each other in the file. And each of them gets transformed into one new line. Okay, let's quit less using Q. So to get rid of those empty lines, we need to use the squeeze option -s for tr. So let's hit up arrow for the previous command and add an option -s here. And the S option will replace a sequence of white space characters with exactly one new line. So let's pipe this to less again. And now we can see that we don't have any more empty lines here. Well, one thing that we do have here are these punctuation characters, like comma and full stop. Now we're interested in word frequencies, and punctuation will interfere with that. So let's get rid of it. Quit less again using Q. What we actually want to do is to remove all the characters which are neither letters nor numbers or new lines. And this, of course, will include all the punctuation characters. And again, we can use the tr command or translate to accomplish this. So tr, and then we're going to use the option -d, which says delete, because we want to delete those punctuation characters. And then I'm going to use the option C, which states that I want to delete the complement of the characters that I'm specifying. That means I want to delete the characters which are not in my list. And whenever you have two options like this, you can combine them under one option, so just -dc. Okay, so we want to remove everything that is not a letter in the English alphabet. So that's A through Z, capital A through Z, lowercase a through Z. And we also don't want to remove numbers. So 0 to 9. And we also want to preserve new lines. And then importantly, we also want to preserve the hyphen, which is used to mark contractions in English. Now, because I have a hyphen here, which is basically the same as a single quote, or actually the exactly same character, I need to change the single quotes of my character list into double quotes, so that the command line interpreter will know where the character list ends. So let's pipe this to less and see what happened. Okay, far better. The only characters we see are letters and numbers. And let's quit less using Q. So what we do now is to sort this file into alphabetical order, and that you can do using the command sort. Now if we check using less again, we can see numbers first, because in the default alphabetical order, numbers precede letters. Then if we scroll down a little bit, we see words starting with A here first, and so forth. Now, all of the occurrences of a word like and will be on consecutive lines in this sorted file. So let's quit list less. So that's why what we want to do is to count the consecutive lines which have identical words on them. So we do this using the unique command and add an option -c. So let's see what that does. So let's scroll ahead a little bit. So previously we had a lot of lines which said and. Now after executing this unique -c command, we have only one line with and it's preceded by 133. And this means that in the original sorted file, we had 133 lines with and. And this is actually the count of the word and written in uppercase in the lifeofb.txt file. Okay, let's quit less. And the final thing that we need to do is to sort this into numerical order, reverse numerical order. So sort -n for numerical. Now this is going to sort it in ascending numerical order. So we're going to get all the words that occurred only one time in the file first. But that's not what we want. We're interested in the really frequent words. So we're going to sort it in reverse numerical order using the option R. And then let's pipe this to less. And there we have it. So now we have a frequency list here. And what we do now is just to redirect this output into the lifeofb.freq file. Now, our command works fine for English, where the great majority of words only use letters A through Z. But if we're working with something else like Finnish, where additional characters like A and Ö are common, or Mandarin, which is written in a completely different character set, this is not good enough. We'll almost certainly end up removing some words altogether or splitting words up. So there's a more general solution called character classes. we can use the alnum class to refer to numbers and letters. So let's replace the A through Z and 0 through 9 list here with the class alnum. Alnum stands for alphanumerical. And let's pipe this to less. I'm using Control E to skip to the end of the line. Pipe it to less, and let's see. The result looks the same. Let's quit using Q. Now, this will work for Finnish and Mandarin as long as the default character encoding of your system is set to UTF-8. And the character encoding basically determines how your system interprets the data in text files and the data it receives as a keyboard input. And you can check that your system is set to UTF-8 using the command locale. So locale and enter. And as long as your lang or lc all variables are set to something ending in UTF-8, you're good. If you don't see UTF-8 here, if you see something like ASCII or C, we can provide you reading materials which show how to change this. We'll also provide more reading materials on character encoding in general.